welcome back. Okay, turn that down a little on my end. Okay. So I've been looking into galactic formations, trying to see what I can find with regard to shallograms, under the premise that there's a relationship ever since seeing. Where did I put that? There it is. This. Not the best quality, I guess. I don't know. Let's go. I think it was M74, yeah. Ever since seeing this image, somewhere along the line I came across this. Specifically right there. These little pockets, chambers that wrap around. Not clear what's going on exactly, but there's chambers. So that really drew my attention to shallograms. So if we go back to shallograms, somewhere in here. Like ones like this. It doesn't show the chambers very much. Maybe that's a chamber, but there are, when that gets sheared enough, it can produce, like in this instance, these chambers. One of them specifically really shows it well. I should probably put the two images together in a Photoshop image and make a more immediately viewable overlay of the two. So a lot of times we'll see like this, but then in this instance we're looking for it actually like shears across it, cuts off enough layers that we can see these chambers adjacent. It doesn't look like this, it looks like chambers that wrap around. Doing it kind of there, but that one just got kind of brought into a mound more so than a conglomeration. Oh man, should I restart? Have this image ready. I have so many shallograms, guys. Images of. So many images. I thought it was lower than this. This one kind of is doing it in a window form. I don't know what exactly to make of that one. Here it is. Very, very similar in nature. Like that angle. It even has this big mass looking thing over here. Although this looks like it goes past that, like around it. The image is a little too zoomed in, like it doesn't show more than this that I'm aware of. I've not seen it extend beyond these boundaries. So this is M74. If we go to like, I think this is a Hubble image. Let's just assume it's Hubble. Yeah, Hubble. Like we can kind of see chambers now that we know that they're present, but they're not as distinct as this image. Also, like right at this line is this. I don't know. I was thinking like wherever these are places that stars are tending to form because of, I guess, a current flow in here that's running into resistance at some boundary that this chamber region is producing. This region must be related then to like a swirling eddy here that happens here that behaves like under Australia in the magnetic anomaly map, where there's the chambers, these subsequent chambers we talked about before, like here. Even though overall it's an ammonite shape, it's just one of these structures, galactic. It's like a galaxy overall, but within it, its structure, it has these repeating chambers that like spiral out. That's kind of my interpretation, more particularly visible over here. So probably in a similar way, like if we look at this, more particularly visible over here than like as we go in. At some point within the spiral, it gets extended enough that it starts to have these more clear, like discrete pockets, or just discrete units, something with discreteness that provides like a unit. So it's like 1, 2, like over here it's not so discrete because it's subtly within it. So this really has kickstarted my recent investigation. I haven't been like not researching so much. Like I haven't made a video in a week maybe. I've just been kind of trying to get a bearing on really exactly what's going on in galaxy formation, like theory, present theory, what basis, things of that nature. It's been a little tricky to find anything. Also, this image, real quick, it just occurred to me. If we kind of imagine right here is like a disc, a elliptical disc that then is stacked on top of another elliptical disc, is stacked on top of another. They kind of go around forming like that. This shows it in a little more discreteness as well. Maybe this is even some subsequent attempt that is like extended from it because of being adjacent to the boundary here. Very, very similar, like throughout. It's incredible. Even the way it does this, has this region here, like here. Let's go to this one. Compare it here. So go back again. Really, I need all the images like next to each other to view, but also maybe like stacked and just cycling. That'd be cool if I did like a stack of the images, like this image, and then this image, and then this image, and was able to stack them well enough that this kind of like looked like it was literally one with the galaxy. Like, that would be so cool. Does this possibly connect? Like, it goes up that way, but also maybe over here. This looks more like it's off of this arm completely. But that little feature there, I don't know. Like it extends, which kind of would suggest maybe there's some crossover, but it looks, if anything, like it's crossover from here over this way. Or if it's spiraling in and it's going in like that. The squareness of this. I can't tell if this center has this structure. It kind of looks like it might. Like across down, not as far down across, generally across this way and then over this way. So it's got a, like, with a little bit of a protrusion over here and faded a bit over here, but like some kind of thing very reminiscent of this. Its shape. I've been thinking all sorts of things, like what could we even be looking at when we look at space? What are we actually looking at? Is it just literally space? I would really like to believe, based on some things I've thought, like for instance, starting from Mercury, like that Mercury supernovas, and then it causes Venus to become the new Earth. And then Mercury itself becomes the new Venus, while a new Mercury is born from the sun, which then cycles to cause Earth to become Mars. Venus becomes new Earth. So this one planet is all of the planets. So it's kind of like Earth is all of those. And then I think Uranus, it's like rotates on its side, or like it's anomalous in some ways. There's poles are on its side. I guess it rotates in its poles, but like it makes me think of Uranus is literally means heaven, and or sky, but heaven, and maybe there's a time when Earth is heaven, like in a state of heaven, the heavenly state, and that like always is eternal, but is also like a moment in time that it is kind of like this moment in time where we aren't really like cognizantly, is that the word? In a state of awareness that we're in a place of literal heaven. Like there will be a time when perhaps Earth is in a state where we are aware we're in heaven, and like that's heaven, and like when people die they go back to that time, which is an actual time in like this scale of time going forward, like 1, 2, 3, 4, 5, like thousands of years past thousands of years, and then somewhere heaven begins, like a moment in time, and then that goes until perhaps the Earth is flooded. Like I kind of think of it as heaven is when Venus becomes the new Earth, and then like the old Earth, which is kind of in our state, becomes Mars, and people move to the new Earth aware of what happened and create a new society that literally is heaven on Earth, and perhaps interacts like across time with like UFOs and things, and creates this world in a way where we as a collective do it and are like at one with each other, so there's no like violence or concern, like things are blissful, heavenly, until basically we give birth to a new species of humans. Adam and Eve come along, and that begins a process of dissension, especially when those among us who move there and are like in heaven, like state of mind, look at the humans and say, those are like us enough that I want to be with them, like sexually. And then that's when like the lines cross, that then we basically shows it's time to restart the process, and like a reset button is pressed, which is the flood. And that's my thoughts. So like, it's possible space represents, since the planets seemingly potentially do, like I've pointed out in the past certain galaxies, like of my steamit, I was thinking that may literally be the Milky Way, because my research really began with Hubble's law. Like, I quit my job as a patent examiner because of Hubble's law and reinterpreting it. As you can see, it's interpreted velocity per distance. So Hubble's law, the further away a galaxy is, the more redshifted it is. And when we look at it, so we say that light is redshifted based on the spectrum that we see like peaks at, which show the absorption and emissions, the emissions based on the absorption of aka what's present. So like, it should be here on Earth, we see the absorption of like hydrogen here at a certain peaks, and so we can tell that it's shifted to a different energy by just aligning enough peaks and like saying, therefore we've determined this galaxy has a redshift of blah 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 blah, which then leads to being translated, because redshift doesn't really like tell us anything. It just tells us the degree of redshift that has occurred, but it doesn't really explain why. So in order to know why, we have to begin to translate, which began with a translation of velocity, as we can see here, which is Edwin Hubble's own calculation. So the first observation of this was coupled with a translation of velocity, because redshift is not velocity, it's just how much the light has shifted. It doesn't tell us that it's because of motion. So velocity means it's the interpretation then that it's because of motion. And that really stems from the fact that galaxy redshift per distance is independent of direction. Like, it doesn't matter which direction in space we look, galaxies tend to follow this trend, to a point where it's become known as Hubble's law, which is really, when we look at this, what physicists do is they say, okay, this is cosmological redshift, and it's not really velocity so much as expansion of space induced velocity. So there's not actual motion, there's expansion of space inducing motion in a velocity sense. So it's still even written in velocity, like here, like kilometers per second velocity, even though it says redshift, kilometers per second is velocity. So it's really just translated. If we look here, velocity, kilometers per second, it doesn't actually mean it's caused by velocity, though. The thing is this correlation is caused by gravity bending light. So we assume, when we look at like this galaxy, the galaxy that this is marked using, we assume that its light traveled in a straight line to reach Earth, and that doesn't necessarily have to be the case. Like, we know that gravitational lensing is a thing. Like here. Like we've seen it here. We've seen it in the smiley face. Like it's a thing that happens also in Einstein cross. Like here, where this is one system with an intermediary that its gravity is bending it around like this. Quasar, foreground galaxy, 4 quasars. So it's bending it around it like that, creating the image of 4 galaxies or quasars, but really it's just one. And so this is a thing that happens, and if there's like an infinite spectrum of particles, there's no real reason to interpret that like we see atoms, we see planets, we see stars, we see black holes. There's no real reason for that pattern to stop, except for like because we haven't proven it to ourselves. We don't allow it to be like integrated into our interpretations fully. Essentially, without the proof, we haven't bothered to consider really the depth of what might occur if we just said, well, let's imagine that pattern, even though we haven't yet found proof, let's just say that larger objects could exist as well as smaller, and that the pattern just continues infinitely. And if that were to be the case, then that would suggest there's a possibility that somewhere down the line there's a large enough object within the local universe that we call the universe. What we see is the universe. There is a overwhelming system so much larger than all other systems that when we that it basically influences the light from all systems as the light reaches Earth to then be gravitationally redshifted or blue shifted. So when light moves towards this object, this hypothetical object presently in what I'm saying, as it moves towards it, it would be blue shifted, but because it's like compressing the light as it moves towards it, it's like additively inserting energy into the light, like it's flowing with the flow, but towards the object. But if it's moving away, it produces a redshift. And so if there's a single system somewhere in our local universe, observed universe, that is doing this, then it's possible that it's bending the light in a figure 8 structure, and then the light can arrive at Earth from any angle at an additive redshift per distance, because it's moving away and then back towards it, which cancel in the radial motion away and back, but then it's orbiting around, which is gonna have a vector of motion away. Like if here's an object, an orbit is away, even though it's like perpendicularly away rather than like directly away. It's like perpendicularly away, it's still away. So it has a vector of motion away, always in orbital motion, and then a canceling vectors of radial motion outward and inward, so that if light is traveling in a shape like this, where it's passing through the object, like neutrinos can pass through the Earth, because it's so massive that it just has space between, like it's composed of galaxies as atoms equivalently, kind of thing, let's say, or something of that nature, to a point where it has a lot of empty space between, just like if 2 galaxies collide, the stars aren't likely to interact, but the gas does. In the same way, this light can pass through without interacting inherently, with this object, and so it just passes through and out the other side, and then it flows in what becomes its magnetic field. So like this light isn't just like there, it's flowing in this object's magnetic field, being gravitationally redshifted per distance because it's flowing in a figure eight, which then adds redshift, which subtly influences the interaction of the light with this singular system that is like stable. It's not changing, like it's just huge. But then as the light redshifts, it's changing, so the interaction of the light with the object becomes like exponential over larger distances. And so basically, we then see Hubble's law breaks down. Like if we go Hubble's law of dark energy, like here's Hubble's law, this dotted line, dashed line kind of thing. Here's observation deviating more up to this way. And that's when dark energy is necessary. I don't know if it's visible so much at this low of a redshift, because redshifts get really high. If it shows up that early at 0.3, it starts to deviate from Hubble's law. It's kind of funny, honestly. It's not a law, it's just a correlation that has become called a law because it allowed for an expansion of space to be introduced as a fundamental of the underlying principles and functions of the universe. When it's not, it's literally illogical. So my thought was maybe some of these galaxies, like because light's doing this, it's possible that the Milky Way emitted light, flowed out in the field of this object, and then returned to Earth, and we see the Milky Way. And for instance, other galaxies. So when it comes to galaxy formation, like sometimes it's possible that we are looking at the same galaxy at different times in different galaxies that we think are different because we haven't accounted for the Einstein cross type of effect on larger scales that that object is doing, which I've since came to call the Great Attractor as the most likely culprit. I didn't name it the Great Attractor. It's an object, the Great Attractor, but I believe this is the most likely culprit, which has a like a duality, a yin-yang with what's called the dipole repeller, which is very cool. Great Attractor, dipole repeller. Here we go. Shapely. So here it may actually be the shapely attractor more so than the Great Attractor that's actually inducing current flows of the light to then produce this, like, whatever's the largest system. It's probably, we're pretty much in an atom here. Here we are, local group motion, local group. Here we are right here. And it's got like a positive negative, I guess, or something from which currents flow away, so repelling. So maybe positive, negative, things that flow to. So an outflow, inflow, possibly a connection between the two somehow. Where like when it flows in here, it actually flows out here, and this is like a huge sphere that these are just the poles of. And we're looking at like a magnetic field of this like sphere. Which is just like a planet, an atom. It's a iterative fundamental particle. So the idea elementary particle, like an elementary particle, is a hypothesis in and of itself. Are this elementary particles are, it says are, they are thought to have no internal structure. Okay, so now we're saying are. Elementary particles are thought to be the smallest known building blocks of the universe. So essentially, somewhere along the line, someone was like, there's probably some building block that makes up the universe. And they called it an elementary particle, and then atoms were discovered, and those were called the elementary particles. But then subatomic particles were detected, and those were called elementary particles, and quantum mechanics deemed itself to be like on the throne of understanding by presenting a list of elementary particles, many of which have not been observed. Besides the point, i.e. quarks at the very least have never been observed, which makes me say, what are you guys doing? But anyway, although that brings to mind Triangle Galaxy, maybe? No, I don't. One of the galaxies I saw recently, maybe it's one of these images. This one. This triangle. Not sure what galaxy this is. Space Triangle, ARP 143, one of the Hall in the ARP images, which I was going into. It's kind of reminiscent of my shallogram doc, like what I've been doing with shallograms. Like this is Scully 13. I mean, I know someone else took these pictures and all, but just that kind of thing. It's kind of reminiscent of that, where there's unique systems that are not just like ammonites, basic ammonites, or like something about these galaxies that he calls the Atlas of Peculiar Galaxies. Something about them that he said, okay, let's put this one in this list. A total of 338 galaxies. And he just compiled ones that he thought were interesting, that were not just like basic in appearance. Where, like, as for instance, if we look at like an ammonite, this is more like what's typically seen when we look at ammonites. Then like this is unique. This, it's just, they're all different here, shallograms. So they have these peculiarities that are like revealing to the process, and that's kind of what he was talking about, is these help us understand the more like simple ones. Realize that the reason why galaxies formed into spiral or elliptical shapes is not well understood. He perceived peculiar galaxies as small experiments that astronomers could use to understand the physical processes that distort spiral or elliptical galaxies. Like this one made me think of this, like this. Where this had spirals out to like a final chamber, and that final chamber became like the nucleus of the chunk that broke off from the center of the ammonite. Like it doesn't always stay stable. Sometimes it breaks off by specific processes. Like maybe it retains a final nucleus or type of thing, final chamber that makes it like when seen in a galactic setting, it looks a lot like this. I don't know. Just a thought I had, like it reminds me of how this does tend to happen with these things. Maybe they even form a new nucleus. Like in my mind, the nucleus is kind of this middle of the spiral, and like as it spirals out, like let's say like this one. Like this isn't necessarily separated from this, but it kind of looks like maybe like it is separated from it enough. Although this also has chambers over here that are starting to show, so the structure must have continued over here. But it just got like weathered down by the eroded down by the flows that were shaping it in the first place. Or like this has the center nucleus, but it's missing what's around it. It's possible the energy flows can spawn like a new system off its back, pretty much. Okay, but I was trying to say something about the Milky Way. I believe I stated it with certainty. Let me just read this. While we may never have a telescope outside of our galaxy so that we can then look in at it, we don't need to do this in order to see the Milky Way galaxy in all of its glory. This is because of a phenomenon known as gravitational lensing. While we are only generally aware of this occurring in such instances as an Einstein cross or an Einstein ring, the reality is that this can occur on a much grander scale. Galaxies that cause Einstein crosses or rings are massive, but they are not nearly as massive as the Great Attractor or Shapley Supercluster. What's up, Roman? In our mapping of the cosmos, we have not accounted for the Great Attractor's gravitational effects on the pathing of light from distant galaxies. Being so massive, its effects are much more drastic than the minimal lensing of a galaxy in an Einstein cross or ring. Rather, its effects are immense and influential throughout the entire length of time that the light travels from distant galaxies. And so because of this, we are able to see optical illusions in the cosmos. Somewhere along the line, I point out galaxies that like should be interacting but aren't. Like there's certain galaxies that are seen physically like adjacent in a way where their gravitational effects should be present, but they're not observed. And so, like in those instances, my point is, well, it's because they're optical illusions. Like it's not actually a galaxy. Where, like when we map the universe, we look in a direction in space. We say there's a galaxy. It is measured to be this far away, and then we map it by putting it on a dot there and saying galaxy NGC blah 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 blah, and like assume that our map is accurate, but if that light, like if we follow that light's trajectory in truth back that way, the way we're looking, and it bends in a figure 8 orbital and goes back around and then comes back and around and back, and then is actually originated from the Milky Way itself, then we wouldn't know that. We would map it as if it was another galaxy over there at that distance in a straight line, even though the light was actually traveling in a figure 8 orbital from the Milky Way itself, outward and back and outward and back and outward and back by this other system's gravitational lensing, and then it just arrives at Earth. And it's possible that we could see the Milky Way. Like, this could be the Milky Way. And that's kind of what I was getting at there. And there's reasons, like essentially, the Milky Way is a fairly typical galaxy on its own, but when paired with its close neighbors, the Magellanic Clouds, it is very rare and could have been one of a kind until a survey of our local universe found another 2 examples just like us. It's possible these 2 examples are the Milky Way at 2 moments in time, because like it doesn't have to travel in a figure 8 10 times. It could just go like part way, like out and back, like a single lobe, or like 3 lobes, or 5 lobes, or 7 lobes, 9 lobes, or even go the other way and come some other location, and just like it, circumstances could produce many images of the Milky Way. So it's possible that these 2 are the Milky Way. With consideration of gravitational lensing, it is highly likely, due to their identical nature, that this image is not one of a separate and distinct galaxy, but rather one of the Milky Way itself and its neighboring Magellanic Clouds. The Milky Way now has a twin or 2. So that's from this, which hopefully I'll link. So that's where we're at with some things. I did do some looking around, and maybe I should. Okay, so these chambers, according to interpretation, these are produced by supernovas pushing out the boundaries. Each of these chambers. Just kind of like what's going on here. Like it essentially it formed a inner ring and an outer ring that had a wall, like a container, and then a current entered in through here, like etched its way in and swirled around within the container and got into the inner chamber as well and swirled in there to a point where it started to produce these like nova centers. Where might I have put it? The Wheel of Time video. I found a bunch of these type shapes all around. Also, it has this. Like a and then overlaying centers of the different eddies that formed in figure eights, depending on when, I guess, it was happening. Okay. And then stellar nurseries tend to be in the arms of galaxies. So again, when we're looking at this one, all these red spots, all these spots, they tend to be in the arms of galaxies where the gas is densest. So that's something, I mean, obviously that's not like a huge whoa, but just something to keep in mind. Like, obviously, that makes sense. That where there's more density, there's going to be bigger objects that are more like galactic, more star-like, more beyond galactic even, than in the voids where there's not material to be combined so much. Maybe there's anti-material in the voids. Like ether filling the space, subtle material that holds the boundary even. It's perhaps like water. Like in a shallogram sense, water is flowing, shaping these shallograms. Like this wasn't shaped by a fossil being embedded in the stone. It was shaped by a flow of currents, including the materials. All the materials within the stone were flowing inside in a water medium that was transporting the materials, and depending on the materials, transporting them differently. So like the dark, subtle shale form the shell of the particle, or the kind of particle of the shallogram, typically, where then the gold, my interpretation is larger grain particles tend to go more towards the center. So this is kind of like if dark matter exists, it's kind of like the Matrix. Still unclear, although I've seen some things that made me reconsider my interpretation of dark matter. Dark matter I've kind of written off. Dark matter, galaxy, rotation. Like this is a typical galaxy rotation curve, where it's very much a flat line. It does have some indications of increasing velocity near the center, where what is expected, I believe, is more like this, I guess. Expected, observed. And I kind of said, well, like this is what we tend to see, is a flatlining of the rotation. But like if we look at the way this is done, what happens is we measure the radius of a galaxy. We say like this angle to this edge, this angle to that edge, and then its distance. So like if we know its distance away and we're able to measure the angle change in the sky from edge to edge of the galaxy, then we produce a calculated radius. And it's really just trigonometry is my point. And it is very much like understandable that this would happen, but also I think that it's relevant, is that when we look at this galaxy, we're assuming that the distance across the galaxy is linear, like 1 to 1, which is typically the case. Like, you walk across the surface of the Earth, every foot is equal to every other foot. There's not really, or meter or whatever, like every amount of distance is reliably the same, the same, the same. Where we just say, like, 3 feet. We don't say 3 feet in like Denver, whereas in Boston it would actually be 7 feet. Like, it's understood that it's a so-called, like, maybe even universal thing that on the Earth. But when we're dealing with black holes, which are themselves not understood, like, they're not different. That's a really critical thing to understand. They're not actually different. They're just like stars. They're just like planets. They're just like atoms. They're just like the whole infinite array of particles that exist. They're not different. What makes them different is that they're so, like, exponentially more massive than the atoms that we're composed of, that they emit beyond the visible light spectrum. And so when we look at them, they just look like voids. And it's possible, though, that they truly produce a visual, like, doing that when we go, like, a missing location in space. Like, if there's a sheet of paper and we're measuring the distance across this sheet of paper, but really the sheet of paper has this protrusion that goes in, is like right at the center, that is actually this huge amount of additional length that's not being accounted for, then it would make sense for galaxy rotation curves to flatten like they do. Because, like, if we look at a solar system planetary rotation curve, something of this nature, they tend to start out very fast closer to the sun, but then at some point they just pretty much flatline. So my thought is maybe they pretty much just flatline. I don't know why exactly it would be different in this regard, nearer. Like, why wouldn't it still have, like, a little drop off? But it's possible that it just hides so much distance that it really hides this whole region and kind of just enters into this region over here, kind of equivalent. I don't know why it would increase, though, going towards it. But that was my interpretation for a while, and still is feasible in my mind, that there's something of that nature where generally distance per distance, actual distance per observed distance, is identical across distances. But in the case of black holes, it may be that they hide a very large amount of distance. So if we look at this image here, down here it says radius and it starts at 0. It's possible that 0 is actually more like over here, like 35. So if we like have a hidden distance that's not being accounted for, that really places these objects further away than they appear, from the center, where it's kind of like a ring, like Saturn. Like, imagine that we're looking at this, and then this, and that's all we see. is like the ring and then the ring with all of this distance in the middle hidden. And every time we see a galaxy, we pretty much see some equivalent of like the rings of Saturn around this black hole center, that when we look at a galaxy, it doesn't look like Saturn. It looks like this. But imagine that Saturn is really present at the center in this in a hidden radius within there. And what we look at here is really much more like looking at only the rings of Saturn and not at all at this. It would look as if there was only like that much length across, when really there's this whole radius at the center not accounted for. That's my point. And so it's possible dark matter it just isn't necessary at all, and has been misinterpreted because it's really unaccounted for distance near the center of galaxies, because we think in terms of theories. Like, galaxies are everywhere I go. Step one of a galaxy formation is the Big Bang. The Big Bang didn't happen, so it's like every other subsequent step is like suspect. It's unnecessary steps that theorists I see are going through, maybe by choice, maybe by force, overwhelming consensus, just convincing them that the Big Bang is valid, even though physics is literally a reductionist science. So to add expansion of space is not physics. It's just artistic. It's like a creative in some way, but it's not physics. That's not how physics works. There's 4 fundamental forces according to physics, because that's as narrowed as we could get it at the time of there being 4. Even though there's really not 4, there's really just gravity, and even gravity is a result of the infinite cosmos. So there's really none of them are fundamental, but gravity could be called the most fundamental of them all. If any of them is fundamental, it's gravity. And the rest emerge from it, just like the light traveling in a figure-8 orbital by the gravity of an object that bends the light back to it and through it, that then produces its magnetic field. Maybe we're already at an hour. This is maybe a good intro. I have images that I didn't even get to. These ones. Some of them were quite interesting. I still gotta finish lecture 2 and 3 of this one. Let's see. Elliptical galaxy. So this was something I was thinking maybe are well elliptical in shape and show little internal structure. So this is from a video called Hubble's Galaxy Classification Scheme, which I'll link. They lack disks, spiral arms, and dust lanes. Their brightest stars are red supergiants. They are classified by the degree of apparent flatness, with E0 being circular, up to E7 as the flattest, being 3 times as wide as high. For E7, Elliptical galaxies come in many sizes, from giant ellipticals of trillions of stars down to dwarf ellipticals of fewer than 1 million stars. Also contain very little, if any, cool gas and dust, and show no evidence of ongoing star formation. Many do, however, have large clouds of hot gas extending far beyond the visible boundaries of the galaxy. So in terms of the periodic table of currents, which I have a playlist of if you don't know what I'm talking about at all, of this concept where there's a chamber. There's a chamber in which current flows, current and then can basically swirl within there, and that behaves as opening space within the chamber, kind of like we were seeing. So the swirl positive is maybe equivalent to a supernova in terms of galactic scale things happening, where it opens up the chamber space and then allows current to flow. Or like this is, I don't know, opens up a chamber space somehow though. Chamber space forms, current flows within it, forms an eddy. Eddies are positive. Then and this is based on Earth geology processes. That this is where this concept came from. So it's basically forming mounds, these dense mounds over here, and then these eddies over here. Dense mound, eddy. Dense mound is a neutron. Eddy is a space where an eddy flows, is an opening. Just maybe a space for maybe the eddy itself is like a way for electrons to interact with this system here. As the current subsequent to it, like stabilizing as a hydrogen atom. So it can form neutrons, though. That's the point. Neutrons, protons are really just mounds, dense mounds that have been compacted by current flow. Like this current is flowing and it's pushing material into a mound. Like if we look at definitely my Earth's undercurrents video with regard to what I'm about to say. If we look at Saurashtra Peninsula in India, where Mount Girnar is, here, current flowed in the Deccan Traps time frame from here due to the doom shape that started here, moved over this way, moved over here, and then here, punctured the mantle, caused the Earth to expand, caused a basaltic current to interact with the doom shape that was here, that then flowed across this way and filled this region, and then created a boundary down here that it flowed along this boundary generally. Then it swirled over here, came in this way, swirled in an eddy while producing a mound. Eddy mound. And then this region was just kind of contained by pressures. So this is kind of like a hydrogen eddy mound kind of thing going on. Down here as well, there's a mound down here. Just like a dense compacted mound. So these things, like a batholith, places that are densely compacted by current flows, behave like neutrons, and probably are neutrons if could be deciphered fully. So when I look at what I was just showing here, it kind of makes me think of that. Like maybe elliptical galaxies are neutrons in some scale, where they're much more just like compacted mounds in the overall process that then they don't have current flows into them because they're compacted mounds. Like under Australia, the current can get into the compacted mound. It has the potential of happening, but it is compacted enough to have like a sturdy boundary that it's just not getting into at the time. So it behaves like a neutron and prevents current flow, outside current flow, from getting in, producing new stars. So it doesn't really produce new stars in these things. They're just compacted mounds. Very little, if any, cool gas and dust, which I don't know what to make of that exactly. No evidence of ongoing star formation. Many do, however, have large clouds of hot gas far beyond, which is maybe like neutrons don't tend to exist alone. Maybe it's reflective of the eddy nearby. I don't know why it would be invisible as a galaxy. I don't know why they wouldn't be immediately apparent as having interactions. This doesn't show it very well. This is kind of my end result. Let's go to maybe helium. Helium, or then forms a second mound in the hydrogen 3, a second proton in the helium 4, or just 2 protons within the chamber. At some point, these eddies can overwhelm the boundaries, so in order to like stabilize the boundaries, it needs these mounds protecting the overall boundary, the outer boundary, from the pressures of the inner eddies. So basically, as more protons form eddies, more neutrons, mounds, need to form to like contain the pressure within. And so that's why like stable isotopes exist, because of the mounds that hold the space of the container stable. Possibly even form in like a batholith. Maybe I'm drawing this poorly, and it really is more like the mound itself is the neutron. Like it's literally like this. Or like a smaller mound itself is a neutron in the case of hydrogen here, like this. Although this one wouldn't really have a chamber at that point. And then like having a mound form here maybe, and then it starts to split with here into 2 neutrons. I don't know. I kind of lean towards what I drew here though, where it actually has space between. Like that happens here again, where current flowed down this way, like in this region, but not so much here at this boundary. Might as well finish these slides for this video. Image of M87. So it's just pretty much just like a blob. Not too exciting in and of itself, just like a huge globular cluster maybe. Elliptical galaxies probably still have like a nucleus. Globular clusters are never elliptical. It really is almost like a globular cluster, where the globular cluster has like a cloud that is then the stars. Whereas, so like it has like a sphere, is what I'm getting at. A sphere composed of the globular, like a globular cluster. Let me pull it. Like something like this, that if you just peer into this, like there's just more and more galaxies. Or stars, sorry. Where it has perhaps a general, like, sphere. Like maybe this is like a planet compared to a galaxy. Like if a galaxy's center is a nucleus, like a star, then maybe globular clusters are like the planets, where they're never elliptical, spheroidal. But then if we could like peer at it in a different wavelength, perhaps globular clusters can have elliptical surroundings of gas or something. With elliptical something. Just something elongated in its motion in the galaxy. Like a tail. But like having a nucleus where it's seen from our angle of atoms looking at stars. Well, like at a globular cluster of stars, so they're not so many stars that it has like the gas around it that is more elongated, showing its elongation by like producing stars. So it only shows that like spherical nature, but it doesn't show an elongated nature as well, because it's too subtle in the case of globular clusters. They don't have enough energy at those locations, but perhaps elliptical galaxies, because they're just composed of more material, allow for us to see the elongation more. I don't know, just a thought. So that's that one. Hour 13. I could try to just keep going. This one's real interesting. This one, the weirdest galaxies. Okay, let me just do this one. This is from Alex Pettit, who studies the structure of galaxies, the formation of galaxies. Very interesting conversation. The structure of spiral galaxies, Phi at I guest lecture. Broadest research interest, why galaxies look the way they do. Bard interacting in a spiral. Spirals are still somewhat problematic. Due to the way galaxies rotate, we shouldn't see any spirals. Some quite interesting side effects of a flat rotation curve. So the flat rotation curve we were just talking about. Bit of an issue for all those spiral arms we see in the universe. When this was rotating, it was like a frisbee, solid rotation. And then like the rotations modeled were not matching observation, essentially. For real galaxy rotations, any pattern on the surface will eventually wind up over time. The winding problem. So it's winds and winds and winds. Like runners' staggered starts. Very much like shalograms at the chakras that even sometimes show such high degrees of winding that they begin to spray the material like it changes the structure of the chakra. First of all, the chakras that are like this become much more like a corkscrew shape. Like this. And then spray material in an arc like this. Like at some point, takes the center core that's there and sprays it. Like that core. Seems related to what's going on here, which we can then kind of take this line of reasoning, perhaps apply it other places, just a thought. Alternative view, the arms and galaxies are not fixed, but instead waves of high density, density waves like a traffic jam in a road. So this is his work, where he modeled the stars and the gas. Kind of forming chambers. Essentially, the objective is to make it look as much like reality as possible. They've definitely done some really good simulations that are pretty persuasive. Okay, I'm just gonna go. I'll talk to you guys in the next one. That's enough. I'll finish this, so then I can't right now. See you guys.